Hi everyone, I'm Apar Sangi, one of the technical marketing engineers for the Cisco Secure Firewall. In this video, we will talk about loopback interfaces, which were introduced in the Threat Defense 7.3 release. Here is a quick overview of the loopback interface. A loopback interface is a software interface that is considered stable once it has been enabled. It will always remain in the up status until the administrator shuts it down. The IP address of the loopback interface can be redistributed using any of the routing protocols like BGP, EIGRP, or OSPF. Alternately, static routes can also be used to reach the interface. The IP address of the loopback interface can be reached through any of the physical interfaces on the device. Let's look at where we can use the loopback interfaces. In the 7.3 release, the loopback interfaces can be used with virtual tunnel interfaces, either as the source of the VTI or as IP unnumbered, allowing the VTI to borrow the IP address of the loopback interface. If you have multiple VTIs, all the VTIs can use the same loopback interface as IP unnumbered and help preserve the IP addresses. Now we'll take a look at a quick demo. Here is a topology. We have the hub FTD with two ISP connections, ISP1 and ISP2. The IP address of the hub towards ISP1 is 100.1.1.1 and the IP address towards ISP2 is 101.1.1.1. The spoke FTD is at the remote branch and has a SPTI tunnel to the hub. The SPTI tunnel on the hub is using a loopback interface as the source, and the loopback interface is redistributed through both the ISP connections. The IP address of the loopback interface is 103.1.1.1. ISP1 is the preferred ISP, so tunnel from the spoke is initially through ISP1. If the ISP1 goes down, the traffic for the VPN tunnel will start using ISP2. The downtime will be minimal and will depend on how quickly the routing protocol in use converges and switches the route to ISP2. Now let's jump to the FMC and see how we can configure and use the loopback interface. To configure the loopback interface on the FTD, we will go to Device Management and edit the settings of the device. In our case, the hub FTD. We'll go to Add Interfaces, and as we see, loopback interface is a new option here, and we'll select it. To add a loopback interface, we have to provide some details like a name for reference, an ID, which is a number between 1 and 1024. A description is optional, but it is recommended to enter one. Then we'll go to the IPv4 tab. Only static IP addresses are supported, and the option will be selected by default. We just have to enter the IP address. Next, we'll go to Add Interfaces again, and this time add a virtual tunnel interface. We'll provide the necessary details to configure the SVTI, like the name, the security zone, and the tunnel ID. For the tunnel source, we will select the loopback interface that we had created earlier. In the dropdown next to it, we will select the IP address of the loopback interface. For a more detailed explanation on SVTIs, please check our YouTube channel for a dedicated video on SVTI. After configuring the VTI, we will save the changes. Now we'll go back to the device management page and edit the settings of the spoke FTD. We'll go to Add Interfaces and add a virtual tunnel interface on the spoke as well. We'll provide the name, a security zone, and a tunnel ID. However, this time we will use the outside interface as the source instead of the loopback. After configuring the VTI on the spoke, we will save the changes. Now we'll go to Devices, VPN site-to-site, and add a new site-to-site VPN topology. We can provide any name for reference. We'll select route-based VTI. Node A will be our hub, and the virtual tunnel interface will be the SVTI we had created earlier. For Node B, we'll select the spoke, and the virtual tunnel interface will be the SVTI we had created on the spoke. The other settings can be left as default, or you may modify them as per your requirements. We'll now save the topology and then deploy the changes to both the devices. Okay, so now that the changes are deployed, let's move to the CLI of the devices and take a look at some outputs. On the left, we have the hub, and on the right side is the spoke. The three routers in between are ISP1, ISP2, and the ISP for the spoke. First, let's take a look at the configuration of the loopback and the virtual tunnel interfaces. As we see, the tunnel source for the VTI is the loopback interface. If you look at the output of the show crypto IKv2SA, we see that the local source address is 103.1.1.1, which is the IP address of the loopback interface. The remote IP address is 1.1.1.1, which is the IP address of the spoke. If we do a show crypto IPsec essay, we can see that the local and remote identities are all 0, meaning all the traffic that comes to the tunnel will be encrypted. Now we'll ping the tunnel interface IP address of the spoke, and we see that the pings are working and the traffic is flowing through as expected. Now we'll simulate the scenario where ISP1 goes down. If we do a show IP route for the hub's loopback interface IP, we see that the route is through ISP1. Now we'll shut down the interfaces on the ISP routers and see what happens. If we check on the spoke, we can see that the spoke is still able to reach the loopback IP address of the hub. But if we check on the spoke's ISP router, we see that the route has changed, and now to reach the loopback interface, we are going through ISP2. And if we pick the hub's tunnel interface IP address, the pings are still working. As we see, the convergence time is minimal and dependent on how quickly the routing updates happened for the traffic to flow through ISP2 instead of ISP1. This concludes our demonstration for the loopback interface. Thank you very much for watching the video. I hope you enjoyed it. See you next time.